Okay, in this video, we're going to talk a little bit about how chemistry plays a role in biology, what we call biochemistry. At least we're going to start talking about that. So we're going to start with atoms. Atoms are the building blocks of all matter, and they are made up of three different subatomic particles: protons, neutrons, and electrons. You see the positive protons there in the nucleus, electrons outside the nucleus, and then the neutrons that are neutral inside the nucleus as well. So protons are positively charged particles found in the nucleus. Neutrons are neutral particles or have no charge, and they're found in the nucleus as well, and they make up most of the mass of the atom. And then there are the electrons. Electrons are negatively charged particles found outside the nucleus in shells or orbitals, and they have a mass that's about 1/2000th that of the protons and neutrons. More specifically, it's 1/1840th of a proton. It takes 1,840 electrons to equal the mass of one proton. So they're really, really small. And we don't really consider them when we talk about the mass. So some atoms are a specific type of atom, or an element, a pure substance that consists entirely of one type of atom. And what determines the type of atom is the atomic number, the number of protons. In this particular one, the atomic number is 6. So there are these things called isotopes as well. Isotopes are atoms of an element that have the same number of protons, so they're the same element, but they have a different number of neutrons, so they have a different mass. And even though they have a different mass, they behave the same because they have the same number of electrons. So some isotopes are radioactive or radioisotopes, and they decay at a set rate from one kind of atom to another by losing particles from their nucleus. Carbon-14 is one of those, and we use that sometimes in dating fossils and things like that. So here you can see all three isotopes of carbon have the same number of protons, the same number of electrons, but different numbers of neutrons. So most of the time, elements are not by themselves. In other words, atoms don't exist in nature as pure elements most of the time. Most of the time they're combined with other atoms to make chemical compounds. The substance formed by chemical combination of two or more elements in a definite proportion. Physical and chemical properties of compounds are usually very different from those of the elements from which they're formed. For instance, water, H2O, is a liquid at room temperature, whereas the two components, hydrogen and oxygen, are gases at room temperature. They're held together by one of the two types of chemical bonds that we're going to talk about. One type of chemical bond, ionic bonds, are formed when electrons are transferred from one atom to another. So there's this thing called the octet rule that says having full outer shells is the most stable arrangement. But most atoms don't have full shells. So in order to get full shells, they can do one of two things. They can transfer electrons, or they can share electrons. Ionic bonds are transferring. And so in this case, we have sodium ions that have one atom in their outer shell, and chlorine that has 7. So sodium donates its one extra to chlorine, and now they both have full outer shells. But now the sodium, because it's got one less negative electron than positive protons, it's a positive ion or a cation, and chlorine now has one more negative particle electron than it does the positive particles, the protons. So it's a negative ion or an anion, and the positive and negative charges attract each other. The other type of bonds that happen are covalent bonds. These are where electrons are shared between two atoms. So you can see here's our shared electrons between the hydrogen atoms and the water atom. So oxygen has 8 total electrons, 2 in the first energy level, 6 in the outer one. So it needs 2 more. Hydrogen has 1, but because it's only got the one level, it only needs 2 to be stable. So by sharing an electron between the two, now they have full outer shells. There's one other important type of, it's not a chemical bond, but it's an attraction between molecules, or an intermolecular force called a van der Waals force. It's attraction is due to slightly positive, slightly negative charged particles near each other. Geckos have these little tiny things on their toes that allows them to stick to the substances at the surfaces that they're walking on, and they can actually kind of walk up the sides of things using these van der Waals forces.